Welcome to my pre-algebra class. We're on Chapter 10, Section 8, and we're working with similar polygons. Similar polygons are polygons that are the same shape but different sizes, and the symbol for similar is the two wavy lines. So these two triangles are similar. They're the same shape, the angles are the same, but the sides are not the same. In fact, this triangle, although not drawn proportionally correct, is twice the size of this one. So the angles are equal. Angle A would equal angle D, angle C would equal angle F, and angle B would equal angle E. And the sides are proportional. AC to DF is the same as CB to FE, and that's the same as AB to DE. And if I know two sides of each triangle, then I can figure out if they're in the same place. I can figure out the proportion. So 4 is to 8, as 3 is to y, and I can use cross products. So I get 4y equals 24, and divide by 4. And I find out that y is 6, which makes sense, that's 1/2. And I can do the same here. 4x equals 40, divide by 4, and x equals 10. So 3/6 is equal to 5/10 is equal to 4/8. So with that in mind, we're ready to try the evens. So get a sheet of notebook paper out and turn to 468, exercises 1 to 20. And we're starting with number 2. We have triangle XYZ is similar to triangle CBA. And by the way, it's one wavy line, not two. So we draw the triangles. Let's do that shape. Let's do a right triangle. And we duplicate that and just make it a little bit bigger, and we have our two similar triangles. And this is XYZ, and this is BCA. And we're given the value 6 for this side, 9, and we're looking for y. We're given the values of 4.5 for side AB and 4 for side AC. And looking at the lengths here, or the letters, XY is in the same place as CB. And XZ, so we could put 9 over X equals XZ. Since I started with this side, I'll put 6 over CA, which is in the same place up here in the letters, which is over 4. So again, I'm looking just to have one unknown. So I'm going to take this side, I'm going to try and find X, so I'm taking the side that corresponds to CB, which is XY. So 9 to X, and then XZ and CA are in the same place on both triangles, and I can see that from the letters. So since I started with this side here, I'm going to put 6 over 4. Now you could do it a different way, but this is fine. Do your cross products, you get 36 equals 6x, divide by 6, and x equals 6. That's part A. There are two parts to these problems. There are two unknowns. Part B is defined y. We can use the same proportion here, the 6 over 4. Since I started with this side, I'm going to start with the y over 4.5 because that's in the same place. If I look at the letters, I can see that Z, Y is in the same place as AB. And then doing cross product, 6 times 4.5 is 20, is 30. Excuse me, it's 27. Get our calculator out here. So he takes 6 times 4.5. We get 27. Equals 4y, and then divide by 4. And 27 divided by 4 is 6.75. So we found our 2 missing sides. Number 4, we have quadrilateral DCB. DCBA is similar to quadrilateral PQRS. Now look carefully at the diagrams in your book on 469, and we're going to set up a proportion to solve and find X and Y. I'm looking for 2 sides in each figure, similar shapes that are given in the same place, so I can use them to set up the ratio. And I can see 27 CB, and QCB is the only side given in the smaller shape. So if I put CB, which is 27, and find the same side in the other one, and CB matches QR, and QR is 36. So I have my first shape over my second shape in the right place. And I want to find both X and Y, so let's start with Y. Y is CD, and CD corresponds to PQ in the other shape, looking at the letters, and that PQ is 48. So if I do cross products and divide, we get 27 times 48, which is 1,000. 296 equals 36y, and then divide by 36. We find out that we get 36. Double check that too. So 36 is the value for y. And that's the first part. Now we have to find x. So we can use the 27 over 36 again. And this time we're looking for x in the first shape. And x is line segment BA, which corresponds to line segment RS, which is 30. So using cross products again, 27 times 30 equals 810. And then divide by 36. We get 22.5 for x. Problem number 6. The length of a rectangle is 12 feet and its width is 8 feet. So here we have 12 and 8. The width of a similar rectangle is 18 feet. And we're trying to find the area of the similar rectangle. So first we have to find the length. So if we have 8 over 18 is the same as 12 over x, and do our cross products, we get 8x equals 12 times 18, which is 216, and divide by 8, we get x equals 27. So we know the length of this one is 27. So its area is length times width. So it'd be 27 times 18. Which is 486 square feet. Problem number 8. Suppose that triangle PQR is similar to triangle MNO, and the length of PQ is 10 centimeters. Can you determine the length of any side of MNO? We cannot. We need to know the ratio of the sides. Problem number 10. Referring to the figure at the right, in the figure's triangle RST is similar to triangle LMN. Find the length of NM. Well, looking at the triangles, NM, NM, we call that X, is in the same place as ST, which has a length of 40. And we'll need to find two sides that are given in, that we can use in the other one. So checking ML is the same as RS, and they're both given. So 21, I'm going to stay with the same side I picked the X on, is to 24. So using cross products, 24x equals 21 times 40. And we get 840. Divide by 24. And we have 35. And then number 12, suppose that triangle ABC is similar to triangle LMN. You know the length of AB, line segment AB, is 4. What is the perimeter of ABC? Well, triangle LMN, its perimeter turns out to be let's see, it's triangle LMN, its perimeter is 21 plus 28 plus, well, let's just draw the shape and then it might be easier to figure out the answer to this problem. So LMN has sides 28, 21, and we figured out 35. And triangle ABC is similar to that triangle. and AB, which is in the same place as LM, is 4. So we could find the two missing sides. X is to 4 as 28 is to 21. That's one ratio we could use. So 21x equals 28 times 4, which is 112, and divide that by 21. Which is 5 1/3. Let's double check this. I'm going to go back and erase this, and we'll do it the way we've been doing it. So I'm going to put x over 28 equals 4 over 21. So we get 21x equals 4 times 28, which is 112. It's going to come out the same, but I just wanted to make sure we keep it similar to what we've been doing. And divide that by 21, and we get 5 1/3. So x is 5 1/3. And then this side here, x is to, this is y. Y is to 35, as 4 is to 21. So cross product's 21y equals 4 times 35, which is 140. Divide by 21. And we get 6 2/3. So if we add the sides up, 5 1/3 and 6 2/3 makes 12. Plus the 4 gives a perimeter of 16. And then 14 through 20, tell whether the two figures of the given shape are always, sometimes, or never similar. So number 14, two rectangles, are their shapes always similar, sometimes, or never? The answer is sometimes. Because you could have a rectangle that is a square. Number 16, two equilateral triangles, all the sides are equal, all the angles are equal, they're congruent, so always, not congruent, but they're always similar, because the angles are always the same. Number 18, two congruent polygons, always. They're congruent, therefore they have to be similar. 20, an obtuse triangle and an equilateral triangle. Well, an obtuse triangle looks like this. Well, maybe we won't see it. Here it is. An obtuse triangle would be this, and an equilateral triangle would be this. And the angles of an equilateral triangle are always 60, where an obtuse has one greater than 90. So the answer would be never. That concludes the even. Be sure to check the back of the book for the answers to the odds.